All right. We have lots of notes today. We're starting Unit 2, which is Inequalities and Absolute Value. Here is our calendar. Don't know why I have two backups. Okay, our calendar for this unit. Why is it blurry? Okay. So I want you to see that we have our test on Wednesday, and we have 2 Wednesdays from now, on the 21st, and we also have an assessment on the 13th. So, let's get started. Linear inequalities is what we're starting. Okay, so I have a couple notes that I want, get all my colors, I want us to take. Okay, so first things first, inequality symbols. Okay, if we use less than or greater than without the equal sign, we're going to use parentheses for interval notation. Okay, this also means that it's excluded. Doesn't touch. Okay, I want you to remember that in Algebra 2 and Algebra 1 you used an open dot to graph this. Okay, for less than or equal to, greater than or equal to, you use a square bracket. Okay, this means it's included because it says or equal to. Okay, means it does touch, and you would use a closed circle to graph this. Now, we're going to be using more of our parentheses and our square brackets strictly because we're turning it into interval notation. That's the whole reason we're graphing. Okay, so another thing I want to remind you is when using the negative infinity or positive infinity symbol, always use parentheses. And the reason being is, y'all, parentheses, you cannot touch it. Okay, parentheses is not like, not parentheses. Infinity, you cannot touch it. Infinity is not a real number. It's not like you can say, oh yeah, I have infinity magnets. I don't know, that was so random. Okay, so you can't have infinity money, you can't have infinity anything. So it's because it's just a symbol to represent that it keeps going. Okay, so you can't touch that. That's why it's always using parentheses. Okay, and then a couple more things that will make more sense as we keep going. Or you're going to use the U, the big U for union. Okay, and remember, or think about it, if I say you can do this homework or go to the football game, I don't know, you don't have to do both. You can do both, but you don't have to. So when I see or, it satisfies one, both, or the other. Okay? If I say and, so if I say you have to do your homework and go to the basketball game or football game or basketball game, okay, if I tell you have to, or if I say basketball and homework, then you have to do both. Satisfies both. Okay, like I said, that will make more sense as we go. Okay, so it says write the following in interval notation and graph. So we're going to graph first and then write it in interval notation. So this says x is less than -6. Okay, well, less, I want you to realize the Ray, I know, if you hold up your left hand makes your less than symbol. Okay, or if you remember like Pac-Man when you were little, like it's eating the 6, so this is less. Okay, it always eats whatever's greater. So x is less than -6. So here's -6. Less is to the left. Okay, and it's less than not equal to, so we're going to use a parentheses. And think about it this way, like it goes to the left forever you're ending your line, so you're going to use the closed parentheses. Okay. Now, I want you to realize when you go to the left forever, that's negative infinity, and when you go to the right forever, that's positive infinity. Now, we don't go to the right forever here, so the way you do this is you read this graph from left to right. So the farthest left it goes is negative infinity, and the farthest right it goes is -6 with a parentheses. Now, remember, we said always use parentheses with your infinity. So there is your interval notation. Okay, this one's a little different. It has 2 pieces, and I want you to know that anytime it has 2 pieces, it's an and problem. Okay, so I have -2 and 6. And I'm going to read it one piece at a time. So I have x, I'm going to read it from letter to number. So x is being eaten, so x is greater than -2. Greater goes to the right, and it's not equal to, so this is starting the line, so it's going to be an open parentheses. Then I have this side where it says x is less than or equal to -6. Less than is the left, equal to is a bracket. Now, this is an and situation because it's together. Where does it satisfy both of those? Okay, well, both is where it's double shaded. So double shaded or overlapping. Okay. So knowing that, we're going to do parentheses -2 to 6. Now, I want you to realize these little extra pieces are not part of your solution because you can't include those because it's not both. Remember, when it's and, it has to be both. Okay, so this one says x is greater than or equal to -6. So I'm going to put my -6 on my line. Greater is to the right. Equal to is a bracket. Okay, right is positive infinity. So I'm going to do bracket -6 infinity. Now these four get a little different because they have words and there's two different pieces, okay? So we need to take it one piece at a time. So let's look at this piece. X is greater, so first off, I'm going to put the numbers. I have -2 and I have -5. What's smaller? Remember, negatives are opposite, so -5 is smaller. I'd rather be in debt $2 than $5. Okay? So X is greater than -2. Greater goes to the right. It's not equal to, so it's a parentheses. X is less than or equal to -5. So less is to the left, equal to is a bracket. Now this is or, so it can satisfy one or the other. Okay, so it's okay that they don't touch because it's anywhere it's shaded. Okay, so I know this goes from -infinity to -5 with a bracket, or remember how I said that up there that you're going to use that U, that means union, unite, bring together, whatever you want to say. It's the fancy math lingo. Okay, parentheses, -2, and it goes to the right forever, which is positive infinity, which always has a parentheses. Okay, so knowing that, let's try this next one. So again, take this one piece at a time. So we're going to put our numbers. We have +2, +5. So X is greater than 2. Greater goes to the right. It's not equal to, so it has a parentheses. And then we have X is less than 5. Well, less is to the left. It's not equal to, so it's got a parentheses. So here again, we have to use the double shaded because it says and. So and is where they overlap. And so it goes from 2 to 5. Now these next two are special cases. Okay, and knowing that, we're going to put our numbers on there. So -3 and 7, -3 is smaller. Here we have -4 and 2. Okay, so again, take it one piece at a time. This is X is greater than or equal to -3. So greater than is to the right, equal to is a bracket. Okay, then we have X is less than 7. So less is to the left, and it has a parentheses. Now, or means it doesn't have to overlap. It's one or the other. Well, I want you to realize this is one line, and it goes to the left all the way forever, -infinity. And then we have the purple line where they're both. And then we also have the other line, the purple line, that goes to positive infinity. So what's happening here is that anything is a solution. This is a solution, or this is a solution, or this is a solution. So this is all real numbers, your fancy R, or you can say from negative infinity to infinity. Okay, so this special case is a little different. We have x is less than negative 4, not equal to, so we're going to have a parentheses. And then we have x is greater than or equal to 2. Okay, this is an AND situation, which means it has to be double shaded or overlapping. There's no double shaded, there's no overlapping, therefore there is no solution. No solution. So these are our special cases of all real numbers or no solution. Go ahead and flip. Now, when it's already shaded for us, and we're not doing the shading, we're going to assume that this is the answers. Y'all, this is already done for us. Fancy bracket, 0 goes to 5 with a parentheses. Now this goes to the left forever, which is negative infinity, and the right forever, which is positive infinity. So left to right, negative infinity to negative 3 with a parentheses, or 3 to the right forever with an infinity, which always has a parentheses. Okay, so that was just kind of a review from graph to answer, interval notation. Now, I want you to realize everything we've done so far had x already by itself. These last 4 do not have x by itself, so we have to get x by itself so we can graph it and find our interval notation. So you do have to graph these, not just solve them, and you do have to find interval notation, not just graph and solve them. Okay, so let's get started. I like to draw my lines. I'm going to do it on all of them. Okay, so knowing that, let's solve. So I know here I'm trying to get x by itself. So we've been doing this a lot. This should not be hard. Okay, 7 minus 7 is 0, and I get 9 is less than or equal to negative 3x. Now I need to get x by itself, so I'm going to divide both sides by negative 3. Now freeze. You have to flip your symbol. So if you don't remember, when multiplying or dividing by a negative, you have to flip your inequality symbol. So let's flip it. Okay, this cancels and I get x. 9 divided by negative 3 is negative 3. So I read this letter to number. X is less than or equal to negative 3. So put my negative 3 on here. Less is to the left. Okay, and it's equal to, so I'm going to do that. Left is negative infinity, so we go from negative infinity to negative 3. There's your answer. Okay, now one thing I do want you to realize, if you like to write it with x first, that's fine. But do you see how your inequality is pointing at x? Well, it still needs to point at x. So when you flip it, you have to flip your inequality as well. Okay? So let's try this next one. This one's a little crazy. It's got 3 different pieces to it. It's 2 inequality symbols. So I want you to realize whatever you do to the middle, you have to do to both sides as well. All 3 pieces have the same steps. So I know I need to get rid of this divide by negative 3. Well, the way I do that is multiply. Multiply cancels division. But if I multiply by a negative, I have to flip my symbols. That's the rule we just talked about. If I multiply or divide by negative, we have to flip our symbol. So negative 3 times negative 2 is positive 6. Negative 3 times this middle piece just cancels your divide by negative 3. And negative 3 times 5 is negative 15. So last step to get x by itself is subtract 1 from all 3 sides. I get x, bring down my symbols, as 5 and negative 16. So negative 16 and 5. Remember, read it. X is less than 5, not equal to. X is greater than negative 16, not equal to. And remember, it's an and situation, so it's where it satisfies both. So negative 16 to 5. Okay, so these are going to take one piece at a time. I'm going to separate the two so I can just tell the difference between my math. So here, getting it x by itself, I'm going to subtract 3 from both sides. Get 7x is less than 21. Divide by 7, divide by 7. Get x is less than 3. Okay, so here, subtract 2, get negative 4x is less than or equal to negative 20. Divide by negative 4, divide by negative 4. I get x, I flip my symbol because I divided by a negative, is 5. So I have 3 and 5 on my number line. X is less than 3. X is greater than or equal to 5. So this is or, so it's okay that they don't touch. Oop, parentheses. Ooh, if I can draw parentheses. Okay, so negative infinity to 3, or 5 to infinity. Okay, now this one is a little different when it comes to graphing, not when it comes to solving. So we're going to solve it the same. We're going to subtract 5 from both sides. We're trying to get x by itself, so we get 2x is less than or equal to negative 2. Divide by positive 2, divide by positive 2, so I don't flip my symbol. X is less than or equal to negative 1. Add 4 to both sides. We get 3x is less than or equal to 18. Divide both sides by 3. X is less than or equal to 6. Okay, I know I'm going a little fast, but it's because I'm just doing this for notes. I forgot to record today. So if you have to pause to write things down, pause to write things down, or slow it down, or whatever you need to do, okay? X is less than or equal to negative 1. Less than or equal to goes to the left. Equal to has a bracket. Okay, x is less than or equal to 6. Well, weird, they go in the same direction. Are they ever double shaded? Well, yeah, they're double shaded here, and they go to the left forever, which means negative infinity to negative 1. All right, your practice is due on Tuesday. Have a great day. Let me know if you have any questions.